Hello everyone, good morning. How are you today? So today we are going to talk about carboxylic. Good morning, Sushant. Good morning. Good morning, Nisha. Yes. So today we are going to talk about our topic of carboxylic acid. Okay, it is from organic chemistry. You know the formula for carboxylic acid, right? You know the structure of carboxylic acid. That is the basic, right? And today we are going to talk about the properties of preparation, properties of carboxylic acid preparation, as well as their chemical property. And then we are going to talk about the PYQs of the carboxylic acid chapter. Okay. So in the previous classes, we have already studied aldehydes and ketones, right? In NCERT, aldehyde, ketone, and carboxylic acids are given. Right? So let's start with the session. I am audible to you and my screen is visible to you, right? Yeah. Okay. So now let's start with our session. So today's first topic is what? Preparation of carboxylic acid. So by using which methods we can prepare carboxylic acid? So first one is from the alcohol. Yes, first one is from the alcohol. Yeah. By doing oxidation of alcohol with the help of alkaline KMnO4 and acid workup, we get the acid. Okay. From cyanide. Second method is from cyanide. Cyanide undergoes into hydrolysis to give amide, which undergoes into acid, or which when we add water to it, or when the amide undergoes into hydrolysis, there is a production of again acid. Next, when Grignard reagent reacts with the CO2 in presence of dry ether and hydrolysis takes place, there is a formation of again acid. So these are very, very important methods. Okay. Next, from the acid chloride. Okay. From acid chloride, from alkyl chloride, acyl chloride. ठीक है, ये जो हमारा acid chloride है, इसका जब hydrolysis होता है, then we get again acid. Next one, very, very important, when there is a benzene. Okay, benzene, substituted benzene is there. It undergoes into oxidation. So if this is a toluene, if suppose instead of R there is a CH3, okay, then it will directly form COOH. This is very, very important reaction. Next reaction which tells us about when amide is present, okay, CONH2 group is present on the benzene. When it undergoes into hydrolysis, there is a formation of acid. Next, very important reaction, when ester undergoes into hydrolysis, we get acid. When it reacts with the base, we get acid. Okay, so these are total 6 methods, very, very important methods. One question is always asked, okay, about the preparation of carboxylic acid. Means reaction can be given, or A is getting converted into B, like that way sequence can be asked, conversion sequence. Okay, any doubt in this? So these are very, very important reactions, right? Next. So what are the properties of these carboxylic acid? So physical properties, when you talk about the physical state of these carboxylic acid molecules, you can see that from C1 to C3, carbon containing carboxylic acid, these are colorless, pungent, smelling liquids. They are liquids and they are smelling liquids. Okay. C4 to C9, they are oily liquids having goat's butter-like smell. So if goat's butter is there, okay, the smell of that will be similar to the oily liquids of C4 to C9 carboxylic acid. Next, C10 plus, colorless and odorless waxy solids. So these are what? Colorless hote hai, and these are what? Odorless waxy wax kind of solids these are. Okay. So all these carboxylic acids are polar substances and they can form hydrogen bonds with each other also, and they can form a dimer structures by forming the hydrogen bonding. So this is very, very important point. Okay, they are polar compounds. They can form hydrogen bond with each other and they can form the dimer structure. Next, again, important thing is that carboxylic acids are, their name suggests actually that they are acids. Okay, so what is the case for acidity of carboxylic acids? So the acidic character of carboxylic acid, why they are acidic? Because due to the resonance in the acidic group, which imparts electron deficiency, that is positive charge on oxygen atom of hydroxyl group. So here you can see non-equivalent structure means what? यहाँ पे only RCOOH I have shown. Okay, the conjugation or resonance takes place and there is a formation of double bond here and positive charge is here. Okay, so this positive charge present on more electronegative element imparts that this hydrogen can go from this. Okay, it can easily go from this compound. So that's why it is what good acid. Acid means what? Which can donate H plus ions, right? So it can go. So due to this resonance, there is electron deficiency, that is a positive charge on oxygen, which is not that much stable, and that's why in order to remove this positive charge from oxygen, it gives out its hydrogen, right? Any doubt in this? Shall I move forward? Okay, next. So how you can prepare, which compounds you can prepare from these carboxylic acids? Okay, so there are certain things. When this carboxylic acids reacts with carbonates and NaHCO3, it gives out CO2. What happens? It gives out CO2. When ethanoic acid is there and you do the acid workup and this type of reaction, when you react with P2O5, that is oxidation, then there is a formation of anhydride there. Anhydride. Okay, it is a formation of anhydride. You know anhydride like this way. Okay, there is a formation of anhydride of ethane. Okay, ethanoic anhydride is formed. Esterification reaction, this is very, very, very important. When acid and alcohol reacts together, there is a formation of ester and water is produced. So this reaction is very, very important, and please remember this. When acid react with the phosphorus pentachloride molecules, okay, it forms acid chloride, PCl3 and HCl. Similarly, if the acid reacts with SOCl2, that is thionyl chloride, then there is a formation of alkyl acid chloride. Okay, this is formation of acid chloride again, and SO2 is liberated and HCl is formed. When the acid reacts with ammonia, there is a formation of a respective amide. When acid undergoes into reduction, there is a formation of CH2OH. So this reaction is converse also. Means alcohol on oxidation gives acid and acid on reduction gives alcohol. Okay, and acid on reduction gives alcohol. So this reaction is what? Vice versa, but reagents are different. See, first में reduction हो रहा है, पहले oxidation हो रहा है, बाद में क्या हो रहा है? Reduction हो रहा है. ठीक है, reduction with the very good reducing agent, that is LiLH4. Okay, next reaction, when the salt of ester, okay, or salt of acid reacts with NaOH and CaO, decarboxylation takes place and there is a formation of alkane and sodium carbonate is what? Liberated. Next, Hell-Volhard-Zelinsky reaction. This is very, 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 very important reaction. Here what happens is that there is what? Which is this reactant molecule? Yes, can you tell me? Yeah, Hell-Volhard-Zelinsky reaction. This is which type of molecule? Do you know the reactant molecule's name? Yes, tell me. Hello. Yes. That is what? Which type of element? Which type of compound? Yes, it is what? It is alcohol. Okay. Is that alcohol? यस, सो यहाँ पे हेल-वोलार्ड-ज़ेलेंस्की रिएक्शन में क्या होता है कि RCH2COOH, यहाँ पे क्या है? COOH है. ओके, सो दिस इज RCH2. One minute, huh? There is some. Oh, yeah, RCH2. Okay, then COOH. When it reacts with X2, that is halogen in presence of red phosphorus and hydrolysis takes place, there is a formation of this kind of molecule. Okay, there is a formation of this kind of molecule, that is R CH COOH हो गया और यहाँ पे लग रहा है हमारा X. Okay, so that is not alcohol, that is what acid only. One O was missing from that, right? Any doubt in this? Yes. Okay. Okay. Now let's go to the next session. Okay, next point. So this is all about carboxylic acid. Very little information, but there are very important questions which are asked from this carboxylic acid. So let's start to solve the problems. First problem, yeah. Can you tell me the answer? Yes. Can you tell me the answer of this? Yes, can you tell me the answer of this? ABCD option. Okay, so let's solve this problem. Okay, what is asked to us? The reaction that does not give us acid, the reaction that will not give us the benzoic acid as a major product. Benzoic acid as major product. What is benzoic acid? You know benzoic acid, benzene is there, and on benzene, acid group is present. It is known as benzoic acid. Yeah, see, okay. Okay, Ayushi. Okay, so we need to find out a reaction that does not give us benzoic acid as a major product. So when you observe first reaction, now here is alcohol which is undergoing into oxidation. Here is alcohol which is undergoing into oxidation. So right now, I have told you that when alcohol undergoes into oxidation, it forms what? Acid. So this will give us the benzoic acid. This reaction, when ketone reacts with NaOCl and hydrolysis takes place, here also there is a formation of acetic acid. Next reaction, alcohol on oxidation with PCC, that is pyridinium chlorochromate. This is what? Controlled oxidation. And that's why in this reaction, alcohol gets converted into its respective aldehyde. Alcohol gets converted into its respective aldehyde. And that's why here, see, acid doesn't form. Okay, this is a controlled oxidation. Even though PCC is an oxidizing agent, it converts alcohol into aldehyde stage. And at that stage, the reaction stops. Okay, so here, that's why here aldehyde is getting formed. We are not getting any benzoic acid. Okay, so that's why here we will get benzaldehyde, and this will be our correct answer. Very good, Ayushi. C is the correct answer. Next, I will just explain the fourth option also. Here also, alcohol undergoing into oxidation with KMnO4. And you know, KMnO4 when reacts with alcohol, there is a formation of what here? Benzoic acid. There is not formation of any other compound. So that's why our option correct answer is what? C. Right? Any doubt in this? Okay, so let's move on to the next problem. Yeah. Which one of the following esters get hydrolyzed most easily under alkaline condition? Yeah, A, B, C, D. So which will undergo into hydrolysis very easily? Yes. Observe all the options. You can see here OCOCH3 is common, OCOCH3 is common, OCOCH3 is common, OCOCH3 is common. What is different? Here chlorine is present, here NO2 is present, here nothing, means hydrogen is present, and here what? OCH3 is present, not COCH3, sorry, OCH3 is present. Okay, so here we need to consider about electron withdrawing effect, electron withdrawing group, as well as electron donating group. What does they do in terms of hydrolysis? So here you should be knowing that electron withdrawing group increases, electron withdrawing group increases the reactivity towards nucleophilic substitution reaction. The reactivity towards nucleophilic substitution reaction. On the other hand, the electron donating group decreases the reactivity towards nucleophilic substitution reaction when it occurs on the benzene. Okay, so that's why here you can see this is what OCH3 is donating. Here nothing is present. Cl is also what? Donating. NO2 is what? Withdrawing. So which will be most easily undergo into hydrolysis in presence of alkaline condition? A compound which contains the electron withdrawing group. So what is that? So option D is our correct answer here. Do you get the idea? Yes. You get the idea here, right? Electron withdrawing group. NO2 is a very, very strong electron withdrawing group. It can withdraw the electrons. Yes. Okay, very good, Lakshmi. Now let's move on to the next problem. So see here, next problem is this one. Consider the following compounds. So I have supplied 4 molecules here. You can see 1, 2, 3, 4. So here you can see what is happening in these molecules. The correct decreasing order of their reactivity towards hydrolysis is. So right now I have told you the concept behind hydrolysis, which type of compound will undergo hydrolysis very easily and which will not undergo into hydrolysis. So here you can see 1, 2, 3, 4, and we need to match their reactivity with decreasing order. So which will be showing highest, which will be easily undergo into hydrolysis. We know that electron withdrawing group जिसपे present होगा वो ज़्यादा अच्छे से it will undergo into hydrolysis. So here this is what? This is benzyl chloride. Okay, benzene is there. Here COCl is there. COCl, COCl, COCl. This is common. Here NO2, which is electron withdrawing group. Here CH3, which is donating. Then CHO, which is what? This is what? Electron withdrawing or donating? Yes, CHO. Yes, CHO is electron withdrawing or electron donating? Okay. Order of this reactivity towards hydrolysis. Can you tell me? I will give you time. Yes. Yeah. So this is electron withdrawing. This is electron donating. This is also electron withdrawing, but not stronger as compared to NO2. So NO2 will be more easily hydrolyzed over CHO. ठीक है? और उसके बाद कौन सा आएगा? Yes. उसके बाद कौन सा आएगा हमारा? CH3 आएगा. Right? या नॉर्मल वाला आएगा? Yes. तो यहाँ पे हमारा आएगा नॉर्मल वाला, मतलब जिसको कुछ भी नहीं है, मतलब ए वाला, फर्स्ट वाला आंसर. And then there will be least hydrolyzed will be what? Which containing electron donating group. So here second over fourth over first over what? 3. Yeah. So which is the correct option here? Second 4 first 3. Second 4 first 3. C option. Okay. Okay, Lakshmi. So समझ में आ गया सबको? Do you get the idea, right? Yeah, very good. So now let's move on to the next problem. Yeah, next problem. So यहाँ पे देखो, I have explained everything. The ease of hydrolysis depends upon magnitude of positive charge on the carbonyl group. Electron withdrawing group increases the magnitude of positive charge, and electron donating group decreases the magnitude of positive charge. Okay, जितना अच्छा positive charge will be present on the carbonyl group, that will be very easily hydrolyzed. Hence, the decreasing order of reactivity towards hydrolysis is this will hydrolyze first, then this, then this, then this. Okay. Yeah. Next problem. So see here what is given to us. In the reactant side, there is a benzene ring on which MgBr is present. So this is what our Grignard reagent, right? RMgBr. So what is R here? R is our benzyl ring. Okay. And then CO2 is present, right? RMgBr when reacts with CO2 and there is a hydrolysis takes place. So you know we have seen this reaction. Where do we have seen this reaction? In the preparation, right? See here in the preparation you have seen the reaction when RMgX reacts with CO2 in presence of dry ether and hydrolysis, there is a formation of its respective acid, that is RCOOH, right? So now what will form here? Yeah, please have a look on this question. So instead of MgBr, in place of MgBr, what will happen? There will be RCOOH. So here what will be the answer? Yes, Ayushi, very good. Here answer will be what? Option B. Okay, here answer will be what? option B. Yes, very good. Now let's move on to the next problem. So sorry, यहाँ पे मैंने यहीं पे लिख दिया है, आंसर यहीं पे था. ठीक है, देखो ये रिएक्शन का मैकेनिज्म you can observe. Yes, from the mechanism also you can get the idea that what is happening here. RMGBr, Mg plus charge. This is a minus charge. This minus will attack on the carbonyl, sorry, CO2 ka CO group, and O minus will form. That O minus then combines with the MgBr. Okay, acid workup will takes place, hydrolysis will takes place. What will happen? There will be what? Here OH will be given, here H will be given, and there will be formation of benzoic acid. So this type of mechanism is takes place here. Okay, any doubt in this? Okay, so let's move on to the next problem. Which of the following compounds give benzoic acid on hydrolysis? So try to draw the structures of this, or if you have the idea what will be the structures of this, then there is no doubt. Okay, you can solve this problem directly also. So which of the following compounds gives benzoic acid on hydrolysis? So hydrolysis is going to take place. Chlorobenzene, draw the structure: benzoyl chloride, chlorophenol, and chlorotoluene. So what will be the answer here? Yes. Yes. Chlorobenzene, benzoyl chloride, chlorophenol, chlorotoluene. B. Okay. So see here, benzoyl chloride, very good Ayushi, is going to give us the benzoic acid, and this is the correct reaction here. Okay, this is the correct reaction here. Any doubt in this? Okay, the option will be what? B. Option B will be correct answer. Okay. Now, next problem. Carboxylic acids have higher boiling points than aldehydes and ketones and even alcohols of comparable molecular masses. It is due to their first option, formation of intermolecular hydrogen bonding, formation of carboxylate ion, more extensive association of carboxylic acid via van der Waals forces of attraction, and formation of intermolecular hydrogen bonding. So what will be the correct answer here? Carboxylic acids, yes, they are having higher boiling points as compared to their respective aldehydes as well as the respective ketones. Yes, do you have any idea of this? Why is this happening? Yeah, very good, Priyadarshani, very good. So why that is happening? Due to the formation of intermolecular hydrogen bonding into the carboxylic acid, their boiling points are higher. When aldehydes and ketones are there, they do not show any kind of hydrogen bonding. So there is a intermolecular hydrogen bonding. See, like this way, due to the formation of intermolecular hydrogen bonding, association of carboxylic acid takes place in this way, right? This is O minus H plus, this is this acid group and this acid group, and they are showing what? Hydrogen bonding. So they have higher boiling points. That's why due to aldehydes, then aldehydes and ketones and even alcohols of comparable molecular masses. Okay, very good. Now next question. Major product of the following reaction is. So what is the major product here? Both COH present, ammonia is present. I have told you, when there is an acid and ammonia reaction takes place and heating is given, what will form? There will be formation of amide. But here two acids are present, right? There are two acids present and NH3 is given. So what is going to form? यहाँ पे दो amine लग गए, ठीक है? Next one is the this. Okay, Priyadarshani, yeah. See, I will see. Okay, answer. We will see the mechanism of this. Yeah. So COH है, यहाँ पे CONH2 है, यहाँ पे COH है, यहाँ पे NH2 है, यहाँ पे क्या हो रहा है? Imide form हो रहा है. Okay, there is a formation of imide here. So let's see the mechanism of this reaction. What happens when there is a strong heating takes place? So first of all, amide is going to form, then amide is going to form. So phthalamide is going to form, which on again heating means heating is going to take place, yes, continuously. So that's why what will happen here is there will be formation of phthalamide, that is option C. Priyadarshani was right. So option C will be what the correct answer, and such type of mechanism will take place here in this molecule. Okay, So our option is what? Answer is what? Option C. Right? Next problem. Correct order of strengths of carboxylic acid is. So what is the correct order of strength? Which acid will be strongest acid in 1, 2, and 3? What do you think? 1, 2, 3. Which acid will be the strongest acid here? First one, a simple cyclohexane COH attached in. In second, oxygen is present. In third one, oxygen is again present, but it is present far further away as compared to the second one. So what do you think? Which will be the correct answer here? 1, 2, 3. A, B, C, D. Yeah. Okay, so here what will happen? See, acidic strength of a given carboxylic acid is directly proportional to minus I effect. Okay, it is directly proportional to the minus I effect. Okay, as you see in the three compounds, oxygen is more electron withdrawing in second compound and third compound, and that's why it shows greater negative I effect than the first one. So that's why first one will have the lesser acidic strength. Okay, it will be least acidic. But out of the second compound and the third compound, what will be the case? So second compound will be more acidic than. Why is it so? Because the distance of oxygen increases from COH group in the third compound as compared to the second compound, and that's why the acidic strength is also going to decrease as the distance of oxygen from COH increases. So that's why which one will be the strongest? So second will be the strongest, then the third one, then the first one. So second, then third, and then first. So what is the correct option here? Option B. Okay. Do you get the idea of this? How to relate this question? Yeah. Okay. Next problem. The correct order of decreasing acidic strength of trichloroacetic acid, trifluoroacetic acid, acetic acid, and formic acid is. So here I have shown the structure. First one is a trichloroacetic acid. Okay, this is a trichloroacetic acid, A molecule. Next one is what? Trifluoroacetic acid, B molecule, trifluoroacetic acid. Next one is a acetic acid and acetic acid, C, and then is a formic acid. So what is the decreasing acid strength? So which will be more acidic here? So we know that right now we have talked that minus I effect increases, COH group becomes more and more electron deficient, and that's why the tendency to lose their H plus ion increases. That is mean acidic strength of a given acid increases. So as plus I effect increases, the acidic strength decreases. Vice versa is true for this. So you know that trichloroacetic acid and trifluoroacetic acid, in both the cases, fluorine is a good what? Fluorine is good electron withdrawing, right? Minus I effect is present of fluorine. So that's why it will be the acidic compound. Then chlorine wala compound, and then formic acid and acetic acid. You can see in formic acid there is no electron withdrawing or donating group present. That's why it will be more acidic as compared to the donating group present into the acetic acid, that is CH3 group. So that's why the correct order of acidic strength for these four molecules will be like this way: trifluoroacetic acid, then trifluoroacetic acid, then acetic acid, and then methanoic acid or formic acid, and then acetic acid. Okay, this is formic acid. Okay, sorry for my. Okay, this is formic acid, and last one was a acetic acid, right? Do you get the idea now? Two problems we have solved here about the acidic strength. Okay, how it decreases and how it increases. Withdrawing group हो गए, minus I ज़्यादा होगा, minus I more, COH group becomes more electron deficient because it withdraws the electrons. So H plus thinks that I can lose this position and I can go to another molecule, and that's why it goes to the another molecule, and the acid which can donate hydrogen very easily is what? A good acid, right? Next problem. Which one of the following is most reactive towards electrophilic reagent? Yes, यहाँ पे आंसर क्या था हमारा? BADC, option A. Okay, option A is correct answer. Next problem. Which one of the following is most reactive towards electrophilic reagent? So now we need to talk about electrophilic reagent here. Yeah. So can you tell me which is the good or most reactive towards electrophilic reagent? CH3O CH3, CH3OH, CH3 NHCOH3, NHCOCH3, CH3 CH2OH. Yeah, which will be most reactive towards electrophilic reagent? Yes. Okay, so यहाँ पे अपना आंसर है A, B, C, D. Okay, so here the answer is what? Option D. Okay, here you can see CH3, 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 CH3 group is common. Here OCH3 is there, OH is there, NHCO CH3 is there. Okay, and then CH2OH is there. So for electrophilic reagent, if electrophile is going to attack, then we should have a good nucleophilic site, right? So option D is the correct option here because it is having a good donation from CH2OH also and CH3 also. So our option will be option D. Any doubt in this? Okay, next problem. An organic compound A on treatment with ammonia gives B, which on heating gives C. C when treated with Br2 in the presence of KOH produces ethylamine, compound A. So यहाँ पे we have given the conversion reaction. We have given the conversion reaction. Organic compound A on treatment with NH3 gives B. B on heating gives C. C when B on heating gives C. Okay. C when treated with Br2. B in presence of KOH produces ethylamine. Okay, there is a formation of ethylamine. Yeah. So this is the reaction. Which compound is the compound A? Acetic acid. Then this is what? Butanoic acid. Then this acid or this acid. What will be the answer? So let's try to summarize the reaction. So here you can see A compound. मैंने लिया कौन सा? Option D. Okay. CH3, CH2, COH. When reacts with NH3, there is will be formation of this type of compound. Okay. COO, NH4. Which on heating will give me the amide. Okay. When amide undergoes reaction with Br2 KOH, this is a Hopman bromamide reaction in which what happens, this CO group leaves the molecule and there is a formation of respective amide. So that's why this is the correct answer, that is option D. Okay. Option D is the correct answer. CH3, CH2, COOH. When reacts with NH3, there will be formation of COO, NH4, which will undergo heating. There is a formation of amide. This amide reacts with Br2 and KOH and gives us the respective amine. Okay. Any doubt in this? Next problem. So what is the next problem? There is an acid which reacts with Br2 in presence of phosphorus, yields dibromo product. Its structure would be. So what will be the structure? A, B, C, D. So first of all, what is reaction Br2 in presence of phosphorus? When there is an acid, carboxylic acid, it reacts with Br2 in presence of phosphorus. Which reaction is this? Yes. Okay, so I will tell you which reaction is it. Okay. So we have talked about this reaction just now. Yeah, see here. This is that reaction. Hale-Wohlhard-Zelensky reaction. Hale-Wohlhard-Zelensky reaction in which acid reacts with acid reacts with halide in presence of red phosphorus and then undergoes into hydrolysis. There is a formation of alpha halide acid. Okay, alpha halo acid is going to form. So यहाँ पे क्या होगा? Alpha halo acid form होगा. ठीक है, तो Br2 in presence of phosphorus, it's a dibromo product. Its structure would be. So what will be the structure of that given compound? Since Br2 and phosphorus reacts with that propionic acid. So draw the propionic acid CH3, CH2, COOH. Okay, when it reacts with this compound, what will happen? Here one bromine will go, right? And another bromine will go here since it is forming dibromo compound, right? So this H2 will go and here there will be formation of bromine and bromine. So which is the correct option here? 1, 2, 3, 4. Yes, alpha position पे halide जाएगा. ठीक है? In Hale-Wohlhard-Zelensky reaction, on the alpha position, the bromine or the halo group is going to be present. Okay, or it is going to add. So here option C is our correct answer. See the reaction. alpha halogens get substituted by X in Hell-Volhard-Zelinsky reaction, right? Yeah, so let's move on to the next problem. Which of the following is the correct representation of order of acidity in the given compound? So we have given the 4 compounds here. Okay, what is the difference between these 4 compounds? Is there is an acetic acid, CH3COOH. Okay, the hydrogen of this CH3 is replaced by different kinds of group. Okay, in the first one, fluorine is there, then there is a bromine, then there is a chlorine. Okay, so such type of acids are present here. So what do you think will be the acidic strength for all these molecules? 1, 2, 3, 4. So we have talked about the acidic strength. Do you have any answers? Anyone? A, B, C, D? Yeah, what I have told you just now, 3 problems. This is the 3rd problem. We are going to talk about acidity. What we have talked, if there is an electron withdrawing group which imparts minus I effect to a given compound, it increases the acidity. It increases the acidity, right? It increases the acidity. So fluorine being a most electronegative element here, you know the electronegativity sequence, fluorine, then chlorine, then bromine, right? Fluorine, then chlorine, then bromine. You know the electronegativity sequence here. So, right? So due to minus I effect of chlorine, what will be happening? It will show the highest acidity. Then chlorine compound will show, then bromine compound will show, and lastly, unsubstituted acetic acid. So what will be the correct option here? Option C. Yeah, Ayushi, very good. So option C will be the correct answer here. Okay, fluorine, then chlorine, then bromine, and then normal acetic acid will be there. So please remember, if minus I effect increases, the acidity for a given carboxylic acid compounds increases. So fluorine is more electronegative. That's why it will impart the withdrawing effect of its will be more as compared to chlorine as compared to bromine. Very good. Okay. Acidity decreases as minus I effect of the group go on decreases. Fluorine being the most electronegative atom, highest. Okay. It will show the highest negative I effect among all the halogens. Very good. Now next problem. We have to complete this conversion. Set of reactions of acetic acid is a product D. CH3COOH reacts with SOCl2. What will form? Yeah, we have talked about this. When acid reacts with SOCl2, there is a formation of what? When acid reacts with SOCl2, there is formation of what? Yes. क्या form होगा यहाँ पे? When acid reacts with SOCl2, there is a formation of respective acid chloride, right? That is CH3COCl. That is what? CH3COCl. And what will happen? SO2 is going to liberate and HCl is going to form, right? Then this molecule undergoes reaction with the benzene. You know now the reaction name of this. When acid chloride reacts with benzene, which type of reaction is that? It is what? Friedel-Crafts acylation reaction. Friedel-Crafts acylation reaction. And what is going to happen in presence of AlCl3? The reaction takes place. Like anhydrous AlCl3 will act as a Lewis acid here. So what is going to form here? Benzoyl chloride, right? यहाँ पे बेंजीन के ऊपर आ जाएगा ये CO और CH3. क्लोरीन निकल जाता है बाहर, right? So next, what will happen? What is given into the next reaction? Which conversion is present? Can you tell me what will happen in the next step? CH3. It is going to react with HCN, right? Going to react with HCN. So HCN. What will happen with the HCN? See, with HCN, what will happen? With HCN, it is going to add to the carbonyl group. CN is going to add here, and O cyanide, and OH is going to add here. Means H is going to add to the oxygen, and CN group is going to add to the carbon. Then next step is hydrolysis. That is H2O dilute acid. Okay, what will going to happen when cyanide undergoes into hydrolysis? There is a formation of respective acid. ये भी reaction हम लोगों ने देखा अभी. साइनाइड का, राइट. सो दैट्स व्हाई हियर व्हाट विल बी द अवर प्रोडक्ट ABCD. साइनाइड नहीं होना चाहिए ना, तो ये साइनाइड है, ये ऑप्शन नहीं होगा. ठीक है, देन हमारा बेंजीन है, उसके नेक्स्ट कार्बन पे ही सब रिएक्शन होगा. सो OH भी वहीं पे होगा, CH3 भी वहीं पे होगा और COH भी वहीं पे होगा. ऑप्शन डी इज अवर करेक्ट आंसर, राइट. ऑप्शन डी इज अवर करेक्ट आंसर. बाकी के ऑप्शंस आप देख सकते हो, यहाँ पे भी साइनाइड है, ये भी नहीं होगा प्रॉब्लम, ये भी नहीं होगा आंसर. Okay, this will not be the answer. In this, extra carbon atom is present. That's why this won't be the correct answer. Right? Any doubt in this? Okay, so let's move on to the next problem. The OH group of an alcohol or the COH group of a carboxylic acid can be replaced by Cl using phosphorus pentachloride, hypochlorous acid, chlorine, hydrochloric acid. So here OH group of an alcohol we have to replace, or the COH group of carboxylic acid can be replaced by Cl using which type of reagent? Phosphorus pentachloride, hypochlorous acid, chlorine or hydrochloric acid. So you can see the reaction. When alcohol reacts with phosphorus pentachloride, there is a removal of OH by Cl. And when acid reacts with phosphorus pentachloride, again there is a removal of OH, means acidic group with COCl. So that's why phosphorus pentachloride, that is option A, is the correct answer here. Okay, any doubt? Next problem. In a set of the given reaction, acetic acid yielded a product C. तो यहाँ पे reaction दिया है. Just we have seen this reaction. When acid reacts with PCl5, there is a formation of what? RCOCl. This is PCl5. Okay. Okay. Then there is a formation of A, which on reaction with, there is a formation of A, which on reaction with benzene and anhydride AlCl3 gives B. Just now we have seen the reaction, and then when reacts with alkyl bromide, that is Grignard reagent, gives C. So हम लोगों ने अभी देखा कि एसिड जब PCl5 के साथ रिएक्ट होता है, there is a formation of what? Respective acid chloride. When acid chloride reacts with benzene in presence of Lewis acid like anhydrous AlCl3, that is what our FC acylation. Then there will be formation of compound B, that is like this way. Okay, when reacts with our Grignard reagent, what will happen? Grignard reagent, here alkyl group will attach and here OH is going to form. That is respective alcohol is going to form when acetone or when ketone reacts with our Grignard reagent. So which is this compound? Option D. Okay, option D is the correct answer here. This is H5, COH, C2H5 and CH3. Next reaction. Ethyl benzoate can be prepared from benzoic acid by using. So here we need to prepare the ethyl benzoate. So ethyl alcohol and diHCl, the options are given. Okay, so we need to prepare ethyl benzoate. So what is the formula for ethyl benzoate? See here, formula for ethyl benzoate is this one. So ethyl and benzoate group is like this way. Okay, this is H5COO C2H5. So we need to prepare ethyl benzoate, can be prepared from benzoic acid. This is our benzoic acid by using alcohol. Which alcohol? Ethyl alcohol in presence of dry HCl. In presence of dry HCl. So this reaction is known as a esterification reaction, and the option here, correct option is what? Option B. Any doubt in this? Okay, next problem. Reduction by LiLH4 of hydrolyzed product of an ester gives. So LiLH4 के साथ reduction अगर हुआ किसका? ester का, then what you are going to get? So see the reaction when ester undergoes into reduction with LiLH4. Okay, reduction LiLH4 a hydrolyzed product of an ester. Okay, जो ester का hydrolyzed product होगा ना, क्या होगा ester का hydrolyzed product? Respective acid, which on reduction in presence of LiLH4 and ether will give us a respective alcohol, that is RCH2OH. So what will be the correct answer here? RCH2OH and ROH. So there are two alcohols we get. How many alcohols we get? Two alcohols. Do you get the idea of this? Yes? Okay, next question. Which one of the following compounds will react with NHCO3 solution to give sodium salt and carbon dioxide? So what is the correct answer here? Which will undergo? You know that NHCO3 is what? Weak base. Okay, it is a weak base. So it can only react with the acid like which type of acid? Yes, so it can only react with the acid like acetic acid. Okay, acetic acid se wo react ho sakta hai. While phenol is what? Weakly acidic, and N-hexanol is neutral. So they do not react with NHCO3. So NHCO3, sorry, NaCO3 के साथ N-हेक्सेनॉल और फेनॉल ये दोनों रिएक्ट नहीं कर सकते बिकॉज वो खुद वीकली एसिडिक है. Okay, so that's why CH3COH will react with the NaCO3 to form CH3CONA, CO2 and H2. They are already acidic. Okay, phenol is weakly acidic. Okay, acetic acid is also weak acid, but phenol will not react with what NaCO3, and N-hexanol being a neutral molecule, it is also not going to react. So both B and C भी option नहीं है, ये भी नहीं है, ये भी नहीं है, तो क्या आंसर है हमारा? Option A is correct answer. Next problem. Which one of the following product is formed when adipic acid is heated? So do you know the structure of adipic acid? Yeah. So I will show you the structure of adipic acid. Okay. See here in this reaction, adipic acid. Okay. The structure is like this way. 1, 2, 3, 1, 2, 3. So when two propionic acid are combined together, there is a formation of adipic acid. It undergoes onto the heating. Okay. It undergoes on heating. What is going to form? Its respective anhydride. You know, when two acids undergo into heating, there is a formation of their respective anhydride. So here you can see there will be formation of its respective acidic anhydride, and that compound is यहाँ पे acid है नहीं होगा, यहाँ पे तो चले गए acid कहाँ गए क्या पता, तो आंसर क्या हो जाएगा? Option A will be correct answer. Yes. Yeah. Next, in acyl halide is formed when PCl5 reacts with an. Okay. When do you think acyl halide is going to form? चैप्टर का नाम क्या है? कार्बोक्सिलिक एसिड. So when acid reacts with phosphorus pentachloride, then there is a formation of acetyl chloride. That's why here answer will be what? Option C. Any doubts? Okay, benzoic acid gives benzene on being heated with X, and phenol gives benzene on being heated with Y. Okay, benzoic acid when we heat gives benzene when heated with X and gives phenol when heated with Y. What is X and Y? So see here reaction. I have written benzoic acid when it heated with X, right? It gives us the benzene. Okay. Phenol when heated gives us the benzene. So what are those compound? X and Y. So what is X? Soda lime. And what is Y? Zn dust. So Zn dust and soda lime, where are the answer? Soda lime and Zn dust, that is option D. Remember these two reactions. ठीक है, जब एसिड सोडा लाइम के साथ रिएक्ट होता है हम लोगों को मिलता है बेंजीन, और अल्कोहल अगर मतलब फिनॉल अगर जिंक डस्ट से रिएक्ट होगा वो भी हमको देगा बेंजीन. ओके, एनी डाउट्स? Okay, next reaction. A is a lighter phenol and B is an aromatic carboxylic acid. Separation of mixtures of A and B can be carried out easily by using solutions of sodium hydroxide, sodium sulfate, calcium chloride, sodium bicarbonate. So here carboxylic acid dissolves in NaCO3, but the phenol does not dissolve. Okay, carboxylic acid can react with NaCO3. Just now we have seen the reaction, but phenol cannot react with the what? NaCO3. That's why here answer will be what? Yes, sodium bicarbonate. Right? Next, the compound formed when malonic acid is heated with urea. So do you know the structure of malonic acid? So I will show you the structure of malonic acid. उसकी जब reaction हो रही है यूरिया के साथ तो क्या form होगा? So the reaction you can see here, when malonic acid, that is CH2, COOH, COH, this is the malonic acid, when reacts with NH2, CO, NH2, that is what? Our urea molecule. Then there is a formation of barbituric acid. Barbituric acid. Okay, this is the structure. CH2, CO, यहाँ पे है CO, NH, NH. Okay, and here again CO. Any doubt in this? This is what? Barbituric acid, option number C. Next, among the following, the strongest acid is. So now we know which is the strongest acid. Yes, CH3COH, CH2Cl, CH2COH, CH2Cl-COH, CH3CH2COH. Yes, which will be the strongest acid? Here we need to use the inductive effect. Right? Strongest acid is that which have minus I effect. And as well as you know that as the withdrawing group distance increases from acid, what will happen? The acidic strength is also going to decrease. So that's why here in this compound, the structure is CH2, CH2, COH, B में. ठीक है, B में ऐसा compound है, यहाँ पे Cl है. C में क्या हो रहा है? सी में यहाँ पे CH2 है और COH है, Cl का डिस्टेंस पास में है, यहाँ पे डिस्टेंस बढ़ गया, दैट्स व्हाई हु विल बी द स्ट्रॉन्गेस्ट एसिड, C विल बी द स्ट्रॉन्गेस्ट एसिड, दिस इज नॉट अ स्ट्रॉन्ग एसिड। यहाँ पे इसमें भी कुछ विड्रॉइंग ग्रुप नहीं है, ये भी स्ट्रॉन्ग एसिड नहीं है, तो इन दोनों में से कौन सा होगा, ये होगा, क्योंकि इसका जो डिस्टेंस है COH से कम है, इसका जो है वो ज्यादा है। ओके, ऑप्शन सी विल बी द करेक्ट आंसर। या नेक्स्ट, विच ऑफ द फॉलोइंग is correct decreasing order of acidic strength? Yeah, methanoic acid, ethanoic acid, propionic acid. Yes, can you tell me the answer? Simple reaction, simple problem. Which of the following is the correct decreasing order of acidic strength of methanoic acid, ethanoic acid, propionic acid, and butanoic acid? You know the structures of these. Methanoic acid, one will be there, that is what formic acid means, what methanoic acid. So can you tell me the answer? Option A. Okay, Ayushi. So methanoic acid, HCOOH, right? HCOOH. Ethanoic acid, CH3COOH, right? Propionic acid और एक बढ़ा दो कार्बन, propionic acid, right? Then butanoic acid और एक बढ़ा दो, चलो 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 जल्दी 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 लिखो. No, COOH, propionic acid. Okay? So यहाँ पे क्या होगा, प्लस इफेक्ट ऑफ द अल्किल ग्रुप इंक्रीजेस फ्रॉम CH3 टू CH3 CH2 टू, तो यहाँ पे इसका प्लस आए हैं, यहाँ पे इसका प्लस आए हैं, और यहाँ पे इसका प्लस आए। किन लोगों का देखो, आई विल अंडरलाइन द ग्रुप्स, यहाँ पे इसका है प्लस आए, इसका प्लस आए, इसका प्लस आएगी, राइट? ब्यूटेनोइक एसिड है ना लास्ट वाला, बराबर ड्रॉ कर रही थी मैं फिर, या यहाँ पे एक और CH2 आएगा, ठीक है? You get the idea, right? I have written in the answer also here. You can see there is an increase of this much group here. Plus I effect जितना ज्यादा होगा उतनी कम acidity होगी. That's why option A will be the correct answer, right? Very good, Ayush. Next problem. Match the compounds of given list 1 and 2. Match करो. Using the codes given below: benzaldehyde, phthalic anhydride, phenyl benzoate, methyl salicylate, phenolphthalein, benzene condensation, oil of wintergreen, size rearrangement. Very good. So what will be the correct answer here? So benzaldehyde, option D is correct here. So benzaldehyde is used in the benzoin condensation. B, that is phthalic anhydride, is used in the phenolphthalein. C, phenyl benzoate is used in the Fries rearrangement. And fourth one, that is methyl salicylate, is used as a oil of water green. So these are the compounds which are used in these reactions, suitable options. Next reaction, or sorry, next problem. Among the given compounds, the most susceptible to nucleophilic attack to the carbonyl group is, यहाँ पे दिया हुआ है COOCH3, CH3CO NH2, ये compound है COOCOCH3, CH3COCl. So what will be the correct answer here? Yeah, here option D is correct. See, because it is most susceptible to nucleophilic attack. The susceptibility of substance toward nucleophilic depends upon how good a leaving group is attached to it. So Cl minus is being a weak base and therefore it is a good leaving group. It is a good leaving group and that's why nucleophile can attack on that CH3COCl very very easily, right? बात अगर बाकी के आप कंपाउंड देखोगे तो वहां पे कहीं पे CH3 है and some place NH2 is present, at some place COCH3 is present. So they are not good leaving group, right? Next, the reactivities of acyl compounds towards nucleophilic substitution. Same kind of problem is asked, but here we have written the name: acid anhydride, amide, ester, and acyl chloride. So what will be the correct answer here? See here. The reactivity towards various compounds have been found to be in the following order. यहाँ पे nucleophilic attack होने वाला है. कैसे होता है nucleophilic attack? So nucleophile attacks on this carbonyl group and O minus forms like this way. So this type of intermediate is present, and when intermediate is formed, after that the O minus balances its minus charge by leaving this group. Okay, and this type of compound is going to form. So we need to find out here the relative reactivities of various compounds have been, for example, for acid anhydride, amide, ester, and acyl chloride. What will be it? Yeah, Ayushi, C option. Okay. So for that, it will be what? First of all, acyl chloride will be there because it is very good. अभी देखा हम लोगों ने, then acidic anhydride होगा, then ester होगा, and then amide होगा. ठीक है, गुड लिविंग ग्रुप किसके पास है, असिल क्लोराइड के पास है, दैट्स व्हाई आयुषी वेरी गुड, ऑप्शन सी इज द करेक्ट आंसर. नेक्स्ट प्रॉब्लम, सेल्फ कंडेंसेशन ऑफ 2 moles. Yes, self condensation of 2 moles of ethyl acetate in presence of sodium ethoxide gives. तो यहाँ पे 2 मोलिक्यूल्स है हमारे इथिल एसिटेट के, इनका सेल्फ कंडेंसेशन होगा और सेल्फ कंडेंसेशन के बाद हमको कौन सा प्रोडक्ट मिलेगा. सो द रिएक्शन यू कैन सी हियर, इथिल एसिटेट सेल्फ कंडेंस्ड हो रहे हैं C2H5, okay, in presence of what, sodium ethoxide, they give us acetoacetic ester and alcohol. So our answer is what, C, option C, that is acetoacetic ester. Yeah, any doubt in this reaction? Should I explain it more? See, ethyl acetate undergoes Claisen condensation in presence of sodium ethoxide involving alpha hydrogen atom in which 2 molecules of ethyl acetate combines together to form acetoacetic ester. So the name of this reaction is what, Claisen condensation reaction. Okay, Claisen condensation reaction. Very, very good problem. And please remember that when 2 ester group undergoes into self condensation, there is a formation of acetoacetic ester and alcohol. Next problem, which of the following esters cannot undergo Claisen self condensation? So can you tell me the answer here? Yes. So the ester having methylene group shows Claisen condensation reaction. Just now we have seen. So the compound that doesn't contain alpha hydrogen atom, okay, that compound is what, option B. Okay, that's why it will be not showing us, it will be not undergo into self condensation. Self condensation, Claisen condensation होने के लिए the primary thing is what, it should contain the alpha carbon atoms. Okay, अल्फा कार्बन के पास अल्फा हाइड्रोजन एटम्स प्रेजेंट होने चाहिए, यहाँ पे नहीं है. ठीक है, दैट्स फाइन. नेक्स्ट, सोडियम फॉर्मेट ऑन हीटिंग यील्ड्स. या लास्ट प्रॉब्लम ऑफ टुडेज लेक्चर. व्हाट इज द आंसर? टेल मी. Sodium format on heating yields. What is sodium format? From formic acid it is going to form. Yeah, sodium format HCOOH. From this it is going to give us the sodium format. Okay, this on heating gives us. Yeah, इसको heat करो. Sodium format on heating yields oxalic acid and water, sodium oxalate and water, CO2 and NOH, sodium oxalate. Yeah, तो इसको हीट करेंगे हम लोग. If we heat this molecule, na, there is a formation of sodium oxalate and water. Sorry, not water, sodium oxalate and H2. That is our option is option B. See the reaction. So in this way, the reaction is going to take place. 2 molecules of sodium format undergoes into heating to gives us sodium oxalate. So this is the name of this compound. When 2 hydrogens of formic acid replaced by 2 sodium atom, the compound name is what, sodium oxalate, and there is a formation of H2 also. So this is what our final product, and our option, our answer will be what, option number B. Okay. So thank you so much for joining in for today's session. Do you have any doubt in this? Yeah, thank you, Lakshmi. Thank you for joining in. Okay.